This is how to solve equations by factoring. In our first example, number 7, our values are quadratic. It's already factored, so we just need to solve it. So to solve, we have r minus 7 equals 0 and r minus 2 equals 0. I just have to solve both sides for r, and then we have our solutions. So to move a negative 7, we add it. R is equal to 7. Same thing here, to move a negative 2, we add it. R is equal to 2. On number 8, we have our first factor is b equals 0 and 7b minus 6 equals 0. Our first one is already done, it's solved, b equals 0. On this one we're going to add 6 to both sides. 7b equals 6. To get that 7 to go away, we divide by 7. So b is equal to 6 over 7. We're going to leave it as a fraction. On number 9, we have our two factors already. Set them both equal to 0. To move the 7 over, we subtract it. And to move the 8 over, we subtract it. On 10, they're factored already. X plus 2 equals 0 and x minus 4 equals 0. To move a positive 2 over, we subtract it. To move a negative 4 over, we add it. And these are called solutions. We are solving the equation. We have n minus 2 equals 0, 2n minus 1 equals 0. Add the 2 over. Add the 1 over. I'm not done, the 2's not by itself yet, so I need to divide. N equals 1/2. X minus 3 equals 0, 4x plus 7 equals 0. Add the 3 to get the x by itself, minus the 7, divide by 4. Alright, now we have them and they're not factored anymore, so I need to factor them in order to solve. So if I factor this one, I know v goes in the front, and then 64 is a perfect square, so I know that it's 8 and 8, which means one's negative and one is positive in order for them to cancel out, because there's no middle term. So negative 8 plus 8 is 0. Negative 8 times 8 is negative 64. When I solve it, I do what I did just barely. I set both factors equal to 0. So I add 8 on this side, v equals 8, and I minus 8 on this side, so v equals a negative 8. And those are our solutions. Factor, solution. We're going to factor our next one. We have n and n. Multiples of 42 are going to be 6 and 7. I need a positive 1, which means the biggest number needs to be positive and the smaller number is a negative. So we factored it. Now we get to solve. N minus 6 equals 0, n plus 7 equals 0. Add the 6. Minus the 7. Factor, we have k goes in front. Multiples of 4 are 1 and 4, 2 and 2. 1 and 4 will give me a 3, 2 and 2 would give me a 4, so I'm going to use 1 and 4. It's a positive 3, so the biggest number is positive, and the smaller one will be negative. So I factored it, now we get to solve. K minus 1 equals 0, k plus 4 equals 0. To move that 1 over, we add it. And to move that 4 over, we subtract it. On the next one, we have factors of x and x. Multiples of 24 are 2 times 12, or 6 times 4. And let's see. It's between these two. Let's do 6 and 4. And they'll both add up to 10 if I do plus signs. 6 plus 4 is 10. Good. 6 times 4 is 24. Also correct. So we are good. Solve it by setting both factors equal to 0. Minus 6 is one solution, and negative 4 is our second solution. Factor 17, we get A and A. 49 is 7 and 7, and to get a negative 14, we need them both to be negatives. So my solution is A minus 7 equals 0. On both, I set both factors equal to 0, which means it's a positive 7 and a positive 7. Last one on this section, we are going to make our factors again. M and M go in front. Multiples of 18 are 1 times 18, 2 and 9, and 3 times 6. 3 times 6 will give us 18, and then to add them up to 9, they both need to be positive. To solve, we set both factors equal to 0. Minus 3 and minus 6 are our solutions for number 18. And that is how you solve quadratics by factoring.